In this video, we'll be looking at lesson 2.4. We're dealing with problem solving. And by problem solving, I mean we're dealing with word problems, the bane of many math students' existence. Here's the Mr. Richmond 6-step process for problem solving word problems. Word problem algorithm. Algorithm just means procedure. All right. The first step I'm going to do when I'm dealing with word problems is read the question sentence. And I know what you're thinking. Read, obviously we want to do that, but I'm being a little more specific here. Read the question sentence. The question sentence is not necessarily the whole problem. It's typically the very last statement that says exactly what it is we're looking for. Okay, read the question sentence first. So I'm not going to begin reading the beginning of the problem. I'm going to read probably the very last sentence that tells us what we're looking for. In life, if you want to find something, you need to know what it is. So start by knowing what you're looking for. Step 2. Draw a picture if possible. And sometimes a picture will be a table for us to fill out. All right. Now, all the time, it won't be conceivable to draw a picture for it. In step 3, here's where the math, specifically the algebra, comes in. We're going to assign a variable. That is, we're going to let x or m or whatever the variable we want to represent what it is we're looking for typically. Step 4, write an equation. It wouldn't be algebra class without an equation. Step 5, solve and check. And step 6, this is, I'm going to call this my real world step. Be flexible. All right. Be prepared that steps 1 through 5 might not get it done. Okay. Possibly ignore 1 through 5. Okay, so in the end, we're solving problems. We're problem solving. So getting the job done is the key. We certainly want to give these steps a try. Okay, and we are trying to learn algebra. So the assigning a variable and writing an equation, that's what we're trying to learn in this class. But I'm about getting the job done. So be flexible and do what you can do. Now, that pretty much concludes the notes. I'm going to jump right into some example problems using my algorithm here. You feel free to continue writing your example problems on down in this area on your note page. These problems are directly from the ebook, and they resemble some that you will have to do on XYZ. All right, so problem number 2. I'm not going to begin reading here. Even though it's pretty short, I'm going to begin reading here. Find the dimensions. I'm looking for the dimensions of some shape. Rectangle. Okay, well, I've now read my the question sentence. Find the dimensions. It's talking about a rectangle. I'm just going to begin by drawing a rectangle. Here's my arbitrary rectangle. So that's steps 1 and 2. Now I'm going to read the rest of the problem. The length of a rectangle is 1 foot more than twice the width. The perimeter is 20 feet. Find the dimensions. Okay, So I know the perimeter is 20 feet, and I hope you know that the perimeter of a rectangle is 2 lengths plus 2 widths. Okay. Our perimeter is 20, but the perimeter is also 2 lengths plus 2 widths. All right. The length of a rectangle is 1 foot more than twice the width. The length of a rectangle is 1 foot more than twice the width. So it looks to me as though our width is sort of our base unit. So I'm going to call this here my width, and I'm just going to let the width be W. I have now assigned a variable. My variable is that W is my width. W equals the width. Okay. It says the length is 1 more than twice that. So this distance here, I don't know what it is, but I know it's 1 more than twice that one. Okay. Well, twice that one would be 2 times W, and 1 more would be plus 1. I want you to see that I've properly assigned this. It says the length is, this is my length, it's 1 more than twice the width. So now I have correct, if this is my width, now this is my length. It's 1 more than twice that one. I've just used a little algebra to assign that. Now I'm ready to go. It says the perimeter is 20. Well, if this side is 2W plus 1, then clearly this side is 2W plus 1. If this side is W, then this side is W. Now I can make an equation. I'm going to add all these up and set them equal to 20. Here I go. W plus W plus 2W plus 1 plus 2W plus 1. I'm just going to save time, write that as 2 times 2W plus 1. All right, and these 2W's here, that I could just call them 2W, combining like terms. This is all going to equal 20. So adding these together, I get my 2W's. Still, I have this. All this is 20. And you can see that this equation here is really the same as this one. The perimeter is 20. I see I have my 2 times my width. And then this is my length. My length is 2W plus 1. We just said that right there. Now I can solve this one. Distributing here, I get 4W plus 2 plus 2W. This is all 20. 2W and 2W is 6W. Plus 2 is 20. Subtracting 2 on both sides. I get 6W is 18. And dividing by 6, I get W is 3. So in my picture, W becomes 3. If W is 3, this one is 2 times 3, which is 6 plus 1, that's 7. So that makes this one 7. Let's add them all together and see if they are indeed 20. 7 and 7 is 14, 17, 20. So we're good to go. So my dimensions are the width is 3 and the length is 7. Okay. Next, right triangle. I'm not going to begin reading here. I'm beginning reading here. The question sentence. How high does the ladder reach along the side of the building? That's what we're looking for. How high does the ladder reach on the side of the building? So we know I need to draw a ladder leaning against the building. There's my building. All right, here's my ladder over here. There's my generic. What they're trying to drive at when they put a ladder against a building is they want you to draw a right triangle. Okay, it says a 25-foot ladder. Well, this side's 25. The base of the ladder is 7 feet from the side of the building. The base of the ladder, this is 7 feet from the side of the building. How high does the ladder reach along the side of the building? This is what we're looking for this time. I'm looking for smiley face. Okay. Well, I hope you remember from geometry the Pythagorean Theorem. It states the relationship between the sides of a right triangle and the hypotenuse. It says that a squared plus b squared is equal to c squared, where this a, b, and c are represented by the legs and the hypotenuse of a right triangle. The legs are a and b, and the hypotenuse is c. Okay, that's going to be important for this problem. Well, so now I'm ready to fill in my a, b, and c. 7 and smiley face, they are a and b. They are the legs. See how they form an L? L for leg. Okay, so I'm going to let smiley face be my A. So this becomes smiley face squared. Plus 7 becomes my B, 7 squared. The hypotenuse, the side across from the right angle, that's my C. Alright, now we're ready to solve. Solve this equation for smiley face. 7 smiley face squared, we leave the same. 7 squared is 49. 25 times 25 times 25 is 625. Solving for smiley face, we'll subtract 49 on both sides. This leaves us smiley face squared is equal to 625. Subtract 49 is 576. Now we'll take the square root of both sides. Square root of smiley face squared becomes smiley face, and the square root of 576 is 24. We do say positive and negative 24, but we're talking about a length here, and length cannot be negative, so the only solution to our problem in context is positive 24, not the negative side of it. So the length of how high the ladder reaches is 24. 24 feet. That is our answer on number 5. You will certainly need this relationship, this Pythagorean theorem. A, B, and C. C is the hypotenuse, the side across from the right angle. All right. Number 6, I first get to the question sentence. Find the lengths of the three sides. It says the lengths of the three sides of a right triangle are given by 3 consecutive integers. I'm not going to completely work this problem. It is worked out on page 126. I just want to talk about how this is a kind of thing you'll see often in math word problems. 3 consecutive integers. That means they're in a row. So when I go defining my variables, this is how I'm going to do it. I'm going to say that I'm going to let x be the first integer. Integer just means a positive or negative whole number. If x is the first one and they're in order, then the next one is x plus 1. That would be the next number, second integer. And so the third one would be x plus 2. Okay, so here we have defined our variables. We can go from there. Check out from your ebook, from the ebook. Check out page 126 and it will show this problem completed. You have one very similar to it on your assignment. Okay, number 9. I'm going to get to the question sentence first. How much was invested in each account if the total interest earned the first year was $960? I'm looking for the amount invested in each account. It says a man invests 1,200 in 2 accounts. If one account pays 10% per year and the other pays 7%, how much was invested in each account? Sounds like he should have put it all in that account, huh? Maybe he didn't know going in. All right, you can see this time they've drawn a table. So instead of a picture, a table is going to be useful here. All right. I want to know how much he's invested in each account. Here you see it says number of dollars at 10%, number of dollars at 7%. So this is what we're looking for. All right. I'm going to come over here and define my variable. I'm going to let x equal the dollars at 10%. Okay. That's the amount of money he's investing at 10%. So I'm going to just put an X right here. All right. That's my dollars at 10%. Well, if X is the dollars at 10%, how much dollars is 7%? The rest of the money. He invested $12,000 total. This amount here is going to be $12,000 minus X. All right. If he did X at 10%, then the rest of it is 12,000 minus that number. Makes sense, doesn't it? The total is clearly 12,000. That's the total amount that he invested. And if I added this one plus this one, I get 12,000 because X and negative X would cancel each other out. All right. Interest on the money at 10%. Well, he's going to get 10% of this X amount. I hope you know that 10% is equivalent. I move this 2 spaces to 0.10, which I simply write as 0.1. So the interest on that is going to be 0.1x. Okay, the interest at 7%, well 7% is 0.07. So I'm just going to multiply 0.07 times this quantity here. 0.07 times that stuff. I'm writing 12K for 12,000 minus X. And the total amount that he received in interest is this quantity, 960. All right. So now I'm ready to solve this bottom equation. We have this bottom equation becomes 0.1x, that's the amount of money at 10%, plus 0.07 times 12,000 minus x, that's going to equal 960. Okay. Distributing here, I get 0.1x plus 0.07 times 12,000 using your calculator is 840. 0.07 times minus x becomes 0.07x. That's equal to 960. Combining these two like terms, 0.1 minus 0.07 is 0.03x plus that 840 is equal to 960. Solving for x, I will subtract 840 on both sides. I get, coming up here with it, I get 0.03x is 120. Dividing both sides by 0.03. And x equals 4,000. X is 4,000. What was X? It was his dollars at 10%. So the rest, 12,000 minus 4,000, he invested 8,000 at 7%. So he invested 4,000 at the 10%, and he invested 8,000 at the, did my little at sign poorly, 7%. So he didn't invest very wisely. All right, that is number 9. You will have a similar kind of investment question.